Yeah. So we'll be starting in a minute. Just allow me a minute. Okay. So first of all, good evening to all. My apologies. Actually, yesterday it was my bandwidth was not working, I believe. Right. So that was the reason. Right. So let me also download this thing so that if someone wants to have a look, data in the stage, he or she can. Let me see where is that recording option. Let me see. Just allow me a minute. There would be some way down the line here to record the video, I believe. Live streaming, YouTube, right? Just a moment. Okay. Okay, so now I'm on YouTube also. So if you want, you can see work from there. Okay, so let's start from very beginning, right? So let me just introduce myself. Am I audible, right? Am I my background noise? Do I get? Are you getting any noise, background, anything? Is okay? The streaming is fine. Anyone want to respond? Is my voice is clear, right? Yeah, okay. So I got one thumbs up, so that's okay. Okay, so now we'll start with this robotics. So let me just give you my introduction. So my name is Dr. Sachin Kansal. So I am working as an associate professor in computer science department, and I have been associated with this institute for the past 5 years, right? And before that, I was a postdoctoral fellow at University of Birmingham, UK, and I did my PhD from IIT Delhi. Right. So I have an expertise in or experience for the past 1.5 decade related to robotics. Right. So I did my post graduation from IIIT Allahabad and recently a visiting fellow at University of Queensland last year. So this is my background. So I typically works in the domain of robotics, computer vision, and machine learning. So ideally, application side, I'm working on the robotics. In the background, where you are getting some learning, I am using all these models, right? And for getting the data right from the scenes, from the understanding of the environment, I'm using computer vision. So if you combine all these three activities, it will become a kind of a mechatronics domain, right? So this is my background, right? So coming back to, let me see whether it's there or not, right? So coming back to my this for this ELC robotics activity. So for this let's say semester, this is just for the introduction, that let's say for example what kind of robotic application you have to explore, right? And I think at the end of this semester, presumably from April or maybe in late March or maybe first week of April, we're going to have a ELC activity on robotic arm, right? So before exploring robotic arm, what we are trying to understand is what is or are the key ingredients or key requirements that we need in order to pursue any project or any kind of an hands-on in robotics, right? So that was the main intention of today. So just allow me a minute. Let me I'm just wondering where I can see the recording option. Just a moment. Don't know whether I have it here or not. Just need to check. Is there any by default option to record the video? Anyone can help me out with this? Hmm. Recording during the start activities. Okay, let me see in the activities. I believe we will be having. So let me see where it is. Yeah. Yes, I can see. But that I think learn about the premium meeting tools. I think it's an unavailable right now. I don't know why. Okay, that's not a problem, right? So that's okay. Fine, no issues. Right. So let me share my screen so that you have a better understanding what I'm trying to pitch you a kind of an idea. So just allow me a minute. I hope my screen is visible. All of you can see my screen, right? Is my screen visible to all? I think it will take some time. Now my screen visible? No, not visible. No. Okay, it's visible, right? Okay, fine. Okay. So ideally, for this kind of an ELC activity, I don't want you to explore, let's say, how it works, right? Before that, we want to explore why you need these subcomponents to make it as something called robotics, right? So from the name itself, robotics came from a kind of a such word called robota, right? It's more like kind of an we call it as automation, right? So this itself, it's kind of an interdisciplinary domain where you club in mechatronics, where you club in electronics, electrical and instrumentation, you club computer science, you club mechanical department, right? So all these things, when you club up together, it will become a kind of a robotics. So robotics itself is not a kind of an, what you call, a kind of a very core branch beforehand. But nowadays, now it become fully mature, a kind of a sub entity. Nowadays every institute or department has some kind of a robotics component, some robotics lab. You name any institute, India, abroad, right? There would be a dedicated lab definitely related to robotics, because where you can tinker the things around, where you can see the things running, where you can see the demos, where you can play around with the motors, where you can play around with the sensors, making some, starting with some toys, right? And solving any small problems, let's say daily household problem. Let's say if I want to get a kind of a reminder whenever my plant got dried, right? Let's say for example, so I just put a moisture sensor inside it. I'll connect with my Arduino or Uno or Nano, and whenever the moisture level go down in my plant, I get a notification from my app, right? Or over my message. We just need to add one sim component over there so that they can communicate over to my message to my phone, right? Let's say for example, if you want to see the progress of your child, let's say if he or she is alone in the home, you just put a camera webcam, you can track the activity, you can classify what is the activity he or she is doing, whether she's playing, whether she's sleeping, right? Let's say for example, if you want to see or track your well-being of your elderly grandmother, grandfather, for example, sitting abroad, you are abroad, let's say for example, and you want to keep track, provided there is some helper in your home, right? So you can track right from their data, right from the multiple IoT sensors, right? So all these things can be possible. I'm not saying these are the kind of an core robotics, but ideally if you attach some actuator within that, because robotics itself comprises of three main components, right? So robotics has a kind of in three sections. First we call as control, second we have sensors, and then we have actuators, right? So there are three combination: control, sensing, and actuate, just like our human body, right? So let's, for example, our mind is more like a controlling the each and every activity of my body, thinking, right? Analyzing, analytic thinking, right? Decision making, right? Understanding the past, understanding the behavior, emotions, everything. It's a very complex network, right? Second is, let's say, sensors, your skin, your ears, nose, tongue, right? Everything is sensing, grabbing the information, right, from the environment, right? And based on that, you do the decision by your control. But where is the actuation? So actuation are your fingers, your legs, your hand, your shoulder, your knees, where you do the actuation. Let's say, for example, if you're playing cricket, right, and let's say if you're doing bowling, right, so it means your actuation is again controlled by your controller, right? Because where you want to ball, whether you want to ball a yorker, whether you want to ball a googly, or whether you want to ball a slower ball or something like this, right? So everything, control, sensor, and actuator are being synced together, right? So this syncing in terms of robotics we call it as calibration, right? So calibration means, let's say, for example, you just need to understand where that object is with respect to that camera or with respect to that sensor. So if you know the position in current world, right, it means your sensors are calibrated with respect to the current state of the art, right? So that was the main intention of any part of the world related to robotics. It would be having some component of majority in control, then minority in control in sensor and actuator. In some entity there is a majority work or majority let's say proportion is of actuator, minority in control and sensor, and so on and so forth. But anyhow, inherently it would be having three components, right, at any low level, higher level, or mid level kind of an robotics application, right? So that's kind of an essence of any robotic application, right? So that's we need to understand, right? Okay, let me see one more time. The call option is not picked. Okay, no problem, right? Okay, so coming back to this again, so there would be a few of the module structure that are overview, right? Let's say, for example, if you want to understand the scene means, let's say, for example, if the robot having a cameras and they are looking for an object, right, and that object is sitting on the table, right? So based on that, what you understand from that scene, okay, there is a 3D object, there is a table, there is a chair. Where is the object with respect to table? Where is the object with respect to chair? Where I am, where the camera is located with respect to object. So all these things is more like called as scene understanding, right? So there are multiple softwares available in order to do the things in simulation. The reason is, we'll try to go like this approach. First we analyze the problem, right, based on what kind of sensor you need, what kind of actuator you need, and what kind of control you need. Control again have two parts, right? So control has, we called as open loop control and closed loop control. So open loop control means, let's say, for example, you are controlling something, but you are not taking any feedback from the environment. It fall in the category of control loop, right? For example, let's say fan, right? Fan is like an open loop. You switch on the fan, right, and it's keep on spinning, right? So your regulator 0, 1, 2, 3 speed are not the control. It's not control, it's just adjusting the speed, because it is not taking any feedback from the environment. The feedback you are giving 0 to 1, 1 to 2 is explicit, right? It's not implicit. In contrary, if you're talking about closed loop environment, closed loop control, let's say, for example, your air conditioner, right? So if you set your air conditioner 24 degrees centigrade, right, and your outside temperature in your room is 26, so it's keep on differencing out the 24 minus 20, 26 minus 24 is 2 degree, right? So it's keep on differencing out until unless your del T is become 0. It means your set temperature should be almost equal to your environment. It means it is keep on sensing the environment, and based on sensing the environment, it is keep on updating they are pushing down their exhaust so that they will suppress down the temperature, right? Again, coming back to sensors, what kind of sensor you need, whether you want cameras, whether you want lidar, whether you want, let's say, IR sensor, ultrasonic sensor, haptic sensor, you name, kind of current sensor, voltage sensor, what kind of sensor you want to use, what is the application, how you can integrate these sensors onto your application. These are we need to explore before working on any of the kind of a real-time problem, or let's say real-time deploy, right? Third is the actuator. What kind of actuator you need? Whether you need DC motors, whether you need servo motor, whether you need BLDC motors, where you need micro miniature level, let's say, motors. What are the RPM you need? What kind of thrust you need? what should be the rating, voltage, current, resistance rating, what would be the output, what would be the, let's say, torque you need to generate. Let's say if you want to lift a very heavy object, right, you need a high torque motors, right? Whether you want to make a small robot where they just do the tiny things, let's say for example moving around the table, a very small one, you need a different rating actuators, right? And everything is compensated with respect to cost, right? So all these things you need to do the engineering homework, to do task, everything, then you will end up with some kind of an making a kind of an a environment where you are clubbing all these things, and now you want to deploy this thing not on physical. You first need to do the simulation. Reason being, if you directly deploy each and everything on the simulation, you might on this physical robot, you might end up with burning out your motors. Reason being, you need to see whether this motor is can sustain on this ampere or this voltage or not, right? What kind of load we are giving to our motors, whether they can sustain or not. So if you want to make a digital twin of your physical model, then you need to do the simulation. Once you do the simulation, give the environment, give the constraint, each and everything, then you can deploy that thing onto the real world, provided you are getting sufficient good results in the simulation, right? So that is the way that I think we have to explore more in the detail in simulation softwares, and then replicating to this ELC as an hardware maybe next month, right? That will be our second ELC, where we will be giving you some manipulator where you have to control it, you have to do calibration of it, you have to do coding, you have to incorporate motor drivers, Arduino, each and everything you have to do of your own. We'll just give a kind of in some kind of an individual pieces of that robot. You have to assemble it, calibrate it, and do the application part, right? So in order to start with, I think I'll be showcasing, or I'll be sharing one document where I'll be asking you to explore any real world problem that is in front of you right now, or in your back of your mind. You are thinking, okay, can't be solved, right? For example, if you're going outside and you will see lots of littering is there, right? Can I build a robot that will just segregate that plastic, glass, and everything, and put it on a conveyor belt, and I can segregate it? Can we make a kind of a mobile based robot where it will pick the object based on segregation, it will segregate, and it will help the society, right? Let's say we'll start with, let's say, Thapar campus, right, for example. So these are the things that we need to explore. So for this activity, I'm not asking that, okay, you have to start with directly deploying it in the real time, but you have to just make sure that, okay, are in a position that where you can absorb these kinds of things, so that you can make some solution from in the terms of robotics, right? First we need to make ourselves kind of an absorbing solvent, right? So that we can see what do you mean by kinematics, what do you mean by inverse kinematics, what do you mean by calibration, what do you mean by sensors, what actually sensors do, what is a baud rate of sensors, right? What is the inference time of a machine learning model? So all these things we need to explore before directly digging into the real world problems, I think, right? So that I think that's the main thing that we need to explore first, right? Rather than just directly digging into the problem solving. So problem solving would not take that much of time, presumably in the era of chat GPT and everything. Understanding the problem, understanding the market need, the current gap analysis, I think it's there is a gray area where we have to find a very kind of an value proportion kind of a thing that we need to understand, right? So I'll be sharing a kind of a problem statements. It would be open problem, it would not be on specific one problem, because I have to deal with 2000 students, right? So I can't give all the students one problem so that they can just do control C and control V. I want you to explore. I'll be sharing a kind of a use case. Based on the use case, you can suggest or you can propose a kind of a robotic based solution. We just need a proposed solution, not the exact solution as of now. And that proposed solution can be used as for your next activity in order to solve that problem what you have proposed so far. All right. So in that domain, I think we can explore more in detail, right? And hopefully today is 19. So by 23rd or maybe 22nd of February, I will be floating a problem statement where you just need to propose a solution with some kind of a tentative guidelines, with tentative benchmarks or constraint. You have to go through it, and then we'll be judging your documents, and based on that we can evaluate what is your approach, what's your thought process. So that we can do as of now, right? So maybe I'll be sharing this thing by 22nd of February, and the last date would be maybe after your MSc. That will be okay, because next week, after next week, you will be having your holy break. Then post holy break, you have 2 weeks of your MST. So I don't want to hinder your MST exams. So maybe post MST we can explore that thing, and we'll be keeping that last date would be roughly around 22 March or 23 March. I think that we can do it. Right. So anything you have in your mind, anything you want to share, you want to ask, anything you have in your thought process, if you want to reach out to me, just Google me, or I'll share my details over here, my email ID or my office number. I work primarily with multiple groups, roughly around 30 groups, if my memory serves me well. It was more than 30 groups. Each group has around 5 or 6 students. So roughly I'm dealing with around 200 plus students with MTech and PhD and so on and so forth, right? So just drop me if you have any idea, any kind of an innovation you want to do in this field, particularly in vision, robotics, machine learning. You can reach out to me, and I'll be sharing this document by 22nd of February. So let me share my email ID if you want to reach out to me, or maybe if you want to drop me a message, or you want to see me in my office. So this is my email ID. I sit at 305 CSED, right? And I sit at Data Science and Center. So these are my two offices, Data Science and AI Center, right? So these are my two offices, right? So this would be office one and office two, right? So office one, and the second would be so my office two. So you can reach out to me. You just drop me an email, right? And if you have some idea, some problem statement you want to explore more in robotics, just go through my website, or maybe my Google profile. Maybe I'll share over here if you want, or maybe I'll share my LinkedIn thing, maybe if you want, so that we can explore more in details. If you want to follow me over here, we can, because I keep on posting multiple things here, right? So let me share my URL if you want to. Yeah, right. Okay, so any queries, anything you want to have, if you have in your mind, just let me know. Yeah, anyone, maybe apart from this ELC activity, any journal query, anything you have in your mind. LLM is nowadays widely used in robotics, primarily in the, let's say, for example, if I'm talking about scene understanding, right? So in the scene understanding, they need to see that what is the environment, what is being already fed in their LLMs, and then accordingly they will do the inferencing. For example, let's say if I ask my robot to pick a smaller, put a let's say a smaller square onto a bigger square, it will do it. But if I ask to do the vice versa, that robot might not do, because it's not a wise thing to put a big block over a small block. So they can run their LLM, Llama, and everything in the background, so that they can see what will be the cost to effective solution they might have, right? Yes, yes, yes. So few of my group, not few, let's say only one or two groups are working on this LLM with some robotics, kind of in manipulation. All both the groups are in their third years and second years. Last year I did my students with the capstone in this domain. We already submitted 2 research paper on this, so it's a widely recognizable domain nowadays. Right. Anyone have any query? You can reach out to me over LinkedIn, right? If you have any queries, you can just message me, or you can drop me an email. You can meet me in my office, right? So I'm very much open, until unless you have a good problem statement with you. You have a zeal in your thing that okay, you want to work something related to this. So I'm pretty much open, and I don't mind putting first year or first semester or second semester students in my project. So I have couple of groups where I have combination third year, second year, first year, second year, third year, first year. Even I've attached MTech student with second year also. So it depend upon your caliber, your if you're a quick learner, you can learn quickly, or you want to explore more in this domain, just reach out to me. Right? Anyone have any query? So this for this activity, just to give an exposure of robotics, I will be sharing a very detailed document so that you can understand. You can maybe treat as like a tutorial, then followed by a problem statement. So it will be not only problem statement, it will be kind of a tutorial exploring the thing with some PPT or with some document attached, and the problem statement based on today's session and based on the shared document. Okay. And if you have any query, or we'll close the session. So that's okay. That was the only. It's like an introduction to the ELC based, particularly for the robotics field. So maybe in the end of March, we'll be having very detailed offline ELC activity where we'll be issuing you the manipulator, sensors, the Arduino board, and everything. Right? Anyone have any query? Anything? Which LLM? So depend upon what's your application, right? So depend upon what's your application. If it can be solved by SLM, right? A small large language model, a small language model that can be solved by SLM, or maybe LLM, maybe it's a Llama, Aero LLM. What kind of? It depend upon the scenario. Depend upon what kind of query you want to generate, and what kind of tokens. What is the quanta of tokens you have to crunching? You have to crunch. So that depending upon the scenario, we can choose. Anyone have any query? Anything? Oh, sounds great. Okay, so I wish you all the best for your MSTs, and definitely I'll be sharing the document, more detailed one, and yeah, right. And you all are in your second semester, I believe, right? Yeah. Okay, and all from different branches, right? Computer science, mechanical, mechatronics, robotics, and AI, right? Different backgrounds, right? Yeah, that sound an ideal audience for me, for a robotics person, right? Someone from CS, someone from ME, control, electrical, electronics. Even few of my students are working under me. They are from biotech, they are from chemical, but we have some kind of an robotics as an application. We recently published a paper with my biotech students. They recently passed out. I think last semester they were graduated. So we recently published a paper, right, related to some eye disease, right? But they are from biotech. Currently, I'm working with the two students from chemistry department. So this domain department, I think, does not have any barrier to work on interdisciplinary thing. I welcome all of you. If you want to pursue, you can reach out to me. You can pass on this information to your friends, make groups, start working, reach out to me, and then yeah, we'll soon meet you offline, right? Okay. Okay. Bye bye. If you don't have any query, I can't see anything over the message. Okay. So that's pretty good to me. Okay, so I'll be sharing this document, right? So, okay, all the best. Take care. Bye bye. Yeah, see you. Bye bye, all of you. Tata.